Hey class, this is lesson 6.1, ratios, proportions, and the geometric mean. Our goal here is we're going to solve problems by writing and solving proportions. So proportions is something that you studied, I believe, in the 8th grade, but it is something that you have already done before. So some basics of it for solving proportions, if A and B are two numbers or quantities, and B is not equal to 0, then the ratio of A to B is A to B, and it's written with a fraction bar. It can also be written, though, as A to B with the little colon, with the two dots in the middle here. So one thing to remember is that we always want to express ratios in their simplest form, or in their lowest term. So we're going to reduce them just like we reduce fractions. So let's say 14 is my length here, and 7 is my width. So if I have length to width, I'm going to do 14 to 7. I just ignore my units, since my units are exactly the same. And reducing that, if I divide them both by 7, it's 2 to 1. So the ratio of the length to width is 2 to 1. So let's try this example. We're going to simplify the ratio. First thing to check is, do they have the same units? So for A, they both have centimeters, so we can just cancel our centimeters out. Well, both of these numbers are even, so we could easily divide them both by 2, but also 4 goes into both of them. So 8 divided by 4 is 2. 76 divided by 4 is 19. So my ratio is 19 to 2. I'm not going to have any units. And notice how I use the two dots, because that's how it was to begin with. B, there are no units here. It's in fraction form, so we're going to keep it in fraction form. 4 goes into both 4 and 24, so 4 divided by 4 is 1. 24 divided by 4 is 6. So my reduced ratio is 1 to 6. C, I've got yards and feet. Now those are different units, so the easiest way to make them just the same is to ask yourself, well, which one is smaller? Feet we know is smaller, so I want to change yards to feet. So I'm going to keep this one 36 feet. I'm not going to change that, but I want to change from 3 yards into feet. And if you think about it, for every yard, there's 3 feet. So I'm going to say 3 yards times 3 feet per yard. And my yards cancel out, and just leaves me with 9 feet. So I have 9 feet to 36 feet. Now that they've got the same units, we just cancel out our units. And both 9 and 36 are divisible by 9. 9 divided by 9 is 1. 36 divided by 9 is 4. So my simplified ratio is 1 to 4. So notice I first checked my units, made sure my units were the same. I had to do some converting here. I then canceled out my units and reduced, leaving my answer in the same form I started with. 150 over 6. Okay, no units here, so I don't have to worry about that. I know both of these are divisible by 3. 150 divided by 3 is 50. 6 divided by 3 is 2. Well, 2 goes into both of those, so I'm left with 25 to 1. And that's in the reduced form. So use a ratio to find a dimension. So this is a good example problem. You'll see this one many times. It says the perimeter of a rectangular table is 21 feet. As soon as I read perimeter of a rectangle, you should have this equation pop into your head. Perimeter equals 2 times length plus 2 times width. It says the perimeter is 21 feet, so in place of the P, I'm going to put 21. It says in the ratio of its length to width, now notice it says length to width. This length is the first thing, and the width is the second. So my length is 5 to, ratio for the width is 2, so 5 to 2. Now this isn't saying my length is 5 and my width is 2. This is saying they're related by some variable. The length is 5 times that variable, and the width is 2 times that variable. So my length is really 5x, and my width is really 2x. Our question here is find the length and width of the table. So I'm going to plug my 5x into my problem for the length, so 2 times 5x, plus for the width, I'm going to plug my 2x, and I'm just going to solve this. So 21 equals 2 times 5x is 10x, plus 2 times 2x is 4x, 10x plus 4x is 14x equals 21. Divide both sides by the 14. And x equals, well, 7 goes into both. 21 divided by 7 is 3. 14 divided by 7 is 2. So x equals 3 halves. Now I found my x haven't found the length and the width yet. So I know my length is 5 times my x, so 5 times 3/2, and my width is 2 times my x, so 2 times 3/2. So my length is 7.5, and my unit here is feet that I'm working with, and my width is 3, and that unit is also feet. The next problem here, the measures of the angles in triangle BCD are in the extended ratio of 2 to 3 to 4. So I've got this triangle, triangle BCD, and in the extended ratio of 2 to 3 to 4, remember that doesn't mean one angle is 2, one is 3, and one is 4. It means one of the angles is 2 times the variable, the other is 3 times the variable, and the last is 4 times the variable. So angle B, I'm going to say is 2 times the variable, angle C is 3 times the variable, and angle D is 4 times the variable. It says find the measures of the angles. Well, thinking about it, the angles of a triangle always add up to 180. So we can make ourselves a little equation here. 2x plus 3x plus 4x equals 180. Well, 2 plus 3 plus 4, that's 9x equals 180. Divide both sides by 9, and x equals 20. Now again, the question here, though, we've always got to ask ourselves, have we answered the question? It says find the measures of the angles. I found x, I haven't found the angle measures yet. So 2x is one, 3x is another, and then 4x. And I know that my x is 20, so 2 times 20, 3 times 20, and 4 times 20. So one angle is 40 degrees, the other is 60 degrees, and my third angle is 80 degrees. So there's my answer. Why don't you pause the video and try this one on your own? Okay, so you should have seen we've got this triangle here. Triangle BCD again. My ratio is 1 to 4 to 5. So notice I put my x's right in there with them. These have to add up to 180, so I can say 1x plus 4x plus 5x equals 180. 1 plus 4 plus 5, well, that's 10x equals 180. Divide everything by 10, and x equals 18. Now the question, though, says find the measures of the angles. So if one of my angles is 1x, that means 1 times 18. The other is 4x, so 4 times 18. The third is 5x, so 5 times 18. So this first one, 1 times 18, is 18 degrees. The second one, 4 times 18, is 72 degrees. And the third one, 5 times 18, is 90 degrees. You could check them by adding them all up and make sure they add up to 180. And if you did that, those three would add up to 180. Okay, so property of proportions. This is called the cross products property, and we're going to use this a lot in this chapter. In a proportion, the product of the extremes equals the products of the means. So if I have A over B equals C over D, so A to B equals C to D, where B is not equal to 0 and D is not equal to 0, then I know A times D equals B times C. So A and D are the extremes, they're the first and the last ones written, and B and C are the means. And that means if I were actually to write these out the long way, A divided by B equals C divided by D. Notice these two are in the middle, that's why they're the means. And these two are my first and last things written, and that's why they are the extremes. Okay, so we do A times D equals B times C. So let's practice using our means, our cross products property. So I'm going to multiply across first, A times C, that's 5 times 16, equals, multiply across here, 10 times x. So 5 times 16, if I multiply that, 5 times 16 is 80, equals 10x. Divide both sides by 10, and x equals 8. Checking this, if I plugged 8 in here, 8 over 16, well, that's 1/2. 5/10, that also reduces to 1/2. So my two ratios reduce to the same thing, so I know it's correct. Let's use the cross products property here. A times D, so 2 times 8, equals 7x times 5. So I have 16 equals 35x. To get x alone, we'll divide both sides by 35. So x equals 16 over 35. Now if we reduce 16 over 35, there's no common factors. So we can't reduce it in fraction form. If we tried to put it into our calculator, we would get a decimal for it. So I'd rather have you just keep it a fraction. So we just keep our answer 16/35. That's the reduced fraction form for that one. Let's look at C here. Now there's a very important thing to know about this problem. When you've got y plus 1 in the bottom, anytime you've got more than one term in one of the top or bottom of either side, you have to put parentheses around it. So when I multiply across and do my cross products property, a times d, so 1 times 3y equals y plus 1, b times c. Well, 1 times 3y is just 3y. To get rid of these parentheses, you have to distribute. 2 times y is 2y, plus 2 times 1 is 2. Let's combine our like terms. This is positive 2y here, so it becomes negative 2y on the other side. 3y minus 2y is just 1y, so y equals 2. And if we wanted to check this to make sure we were right, this is 1 over 2 plus 1, which is 1/3. This is 2 over 3 times 2, which is 2 over 6, and they both are divisible by 2. 2 divided by 2 is 1, 6 divided by 2 is 3. So they both reduce to 1/3, so we know our proportion is correct for y equals 2. I like this example problem. It's a really great example of when we actually use this. So as part of an environmental study, you need to estimate the number of trees in a 150-acre area. You count 270 trees in a 2-acre area, and you notice that the trees seem to be evenly distributed. Estimate the total number of trees. Okay? So we're going to write a proportion with this. We want to write a proportion because that's what we're using here. And we're given that we know 270 trees are in 2 acres. So I can say 270 trees per 2 acres. Okay? That's one side that I know right away, one ratio that I know. Now on my other side, I want to make sure my units line up. Whenever you're writing proportions, you got to make sure units line up. So I need trees over acres. For my other side, it says I want to estimate the number of trees in a 150-acre area. So my 150 has to go with acres. I don't know how many trees there are, so I'm going to put x. There's my variable. Remember back to the beginning, we said when our units are the same, they're going to cancel out. So we've got trees and trees, they cancel. And acres and acres, since they're the same, they just cancel. So again, let's cross multiply. A times D equals B times C. So 270 times 150 equals 2 times x. If I'm going to solve this for x, I'm just going to divide both sides by 2. So x equals, if you multiply that and then divide by 2, you'll get 20,250, and our unit is trees. So we want 20,250 trees. Okay, our next thing that we're going to look at is geometric mean. Now, geometric mean is one of those ideas that is so simple, students just get it wrong. They try and make it more difficult than it really is. So the geometric mean of two positive numbers, a and b, is the positive number x that satisfies a to x equals x to b. So if we cross multiplied here, we'd have x times x, which is x squared, equals a times b. Then to undo that squared sign, you take the square root of both. So x equals the square root of ab. So all you have to do to find the geometric mean is you multiply the two numbers, 16 times 48, and then you take the square root. Now there are two ways of doing this. You could say 16 times 48 and do the square root in your calculator, and you'd get about, I believe it's about 27.71. Okay, and that's a rounded value. Now if we want exact values, there are times where you will have to use exact values. You'll have to simplify your radicals. In GOA, you do not have to do that for my class. Other classes you may have to in GOA. GOB, you definitely are going to have to know how to do this. So let's just simplify this into our radicals. So we're going to look at what perfect squares go into 16 and 48. So perfect squares are numbers that when you take their square root, you get a whole number. So like 1. 1 times 1 is 1. The square root of 1 is 1. 4. because 2 times 2 is 4, so the square root of 4 is just 2. 9, the square root of 9 is 3. 16, square root of 16 is 4. 25, square root of 25 is 5. And then you'd follow that pattern, but these are what we call perfect squares. And if I want to reduce a radical, I'm going to use these perfect squares. So 16 we know is a perfect square. 48. Well, 16 goes into 48, so I'm going to split that up into the square root of 16 times, let's see, 48 is 16 times 3, so the square root of 16 times the square root of 3. So see how 16, I've still got this first 16 here, and I've got 16 times 3, and I'm giving them all the radical. Now I'm going to actually reduce. The square root of 16 is 4, times the square root of 16 is 4. I can't do the square root of 3, so I keep it the square root of 3. And then 16, or 4 times 4 is 16 square root of 3. So this would be the answer in reduced radical form. This would be the decimal form. I'm okay with you using the decimal form in my classroom for now, but if you actually put this in the calculator, that would be the same value. Okay, this is the end of the lesson. If you have any questions, please make sure you've starred them. Make sure you are ready to ask any questions that you have in class tomorrow. And have a great day.